So we're going to cover trig functions. Have any of you guys heard of this? It's called SOHCAHTOA. No. Okay, so SOHCAHTOA is something that used to be taught in the 8th grade. They took it out, they moved it all around, and now it landed up in geometry. Okay, so SOHCAHTOA is what we would use for a right triangle trig, and right triangles only. You cannot use it for regular triangles. Okay, so S stands for sine, C stands for cosine, and T stands for tangent, and all three of those can be found on your graphing calculators, right? So one of my teachers way back, besides remembering SOHCAHTOA, because sometimes they got the letters mixed up, they taught it as some old horse caught another horse taking oats away. They taught us that so that we would remember it. All right, the O in SOHCAH and TOA stands for the word opposite. The A stands for, does everybody know what opposite means, by the way? Like as far as directional? Like who is opposite of me right now? Yeah, like you guys, you're across from me. So when I say opposite, I mean across from. And when I say A, I'm talking about adjacent. So when I say adjacent, I mean next to. And then the H stands for hypotenuse. That's one of the sides of the right triangle. Okay, so if you're looking at your right triangle, the easiest one is the hypotenuse. The slanted. It should be the slanted, but they may try to tip your triangle. So it make one of the other sides look slanted. You just know that it's always directly across from the right angle. So this right here, I'm going to, wherever the arrow points to. Okay, that's the hypotenuse. So now I'm going to put some numbers on here. I'm going to say that this one is 5, this side is 12, and I'm going to call the hypotenuse 13. Now when I mean side, I don't mean C. This side CB is 12. Okay, so it's not a point that's the number, it's the side itself is 12. Okay. Now, they're talking directly about angle A in this case. So you can see A, and A. So what they're referring to is angle A right here. Okay. So I want to label more. I need more. This side clearly hypotenuse. Okay. What side is opposite of this angle? Not B, the 12. Remember, B is an angle, not a side. This would be opposite. This is already taken. This is already hypotenuse. That makes this the what side? That makes this side, yes, the adjacent. Okay, so we know 12 is the opposite, 5 is the adjacent. So what I'm going to do is I'm going to actually fill in those numbers. This part's the easiest part. Okay, so sine of A is the opposite, which is what number? 12, over the hypotenuse, which is what number? 13. So sine is 12 over 13. Oh, for me to write with. All right, so when we're doing cosine of that same angle, it's adjacent, which is 5, over hypotenuse, which is 13. Okay, so basically all we're doing is setting up the trig ratios. Okay, so this part's the easiest part. We're going to get to some stuff that's a little bit more challenging in a minute. Okay, and then tangent would be opposite over, so yes, 12 over 5. Okay, any confusion there yet? We're doing okay. We understand what opposite, adjacent, hypotenuse, and all that are. All right, next thing. Most of your calculators are already in this due to first period and second period did this, but be mindful. When we're working with this, we need to be in our calculator in degree mode. Okay? Why? Because we're dealing with degrees and not radians. So I'm going to teach you how to do this. Please make sure you adjust your calculator, as not every calculator was used. Okay, so if you go to your calculator, turn it on. There's this button right down here that says mode. Touch mode, please. And make sure, I'm trying to get it so that that light's not there. Some of you guys, it's highlighted on radian. You want to go down, go over to degree, and hit enter. That way, this is highlighted and not radians. Okay. So from there, to exit this screen, you just do nothing more than second mode again, which the word quit is above it. So it quits out of that screen for you. Okay, you can do clear. That works too. Now we're just going to do these. So the trig buttons are here, sine, cosine, and tangent. So we're just going to do sine. And that should appear on your calculator. Then you type in 35. And then you don't put the degree symbol. You just need to close it now and hit enter. Okay, so the sine to 35 is how much? So if we read our papers, it says to the nearest hundredth. This number right here would be a 7 because that 3 is not enough to round this 7 up. The 7 is in the hundredths position. So remember, it's tenths, hundredths, thousandths, 10,000ths, 100,000ths, and so forth and so on, the same as it would be to go up the other way in the number line. Okay, so let's do the next one, cosine. So you just hit cosine, 35, and close it. What does that round to? 0.82. Is the pen better to see, Lexi? Besides being on your phone? Stay off your phone. Tangent of 35. Okay, now the question that I got earlier was, since this rounds to 0.70, the question was, do I need the 0 right here? Yeah. Yes, it holds the hundredths position. They meant, could I just write that? No. Nope. That's the tenths position. That showed that you were rounding it to the tenths position. This shows you understood hundredths. So be mindful of that. You do have to put place values where they belong. Okay, everybody good there? We understand how to put sine 35 in the calculator, so forth and so on? Okay. All right, now we're going to work on setting up some more trig ratios. Okay, what was sine? No. I'm writing it again. It's right here as well. What was sine? Opposite over hypotenuse. So I don't want a value yet. I don't want a value yet. I want to know what was I supposed to be setting up. So both of these are opposites over hypotenuse. What's cosine? Adjacent over hypotenuse. And tangent is what? Opposite over adjacent. No. Okay, so being careful, they're talking about R in all three of these. So they're talking about this specific angle right here. Now, if I look, first off, where's the hypotenuse? this side is never going to change. That's going to remain the hypotenuse no matter what angle I'm talking about. Second thing, you will never do sine, cosine, or tangent of the right angle, ever. Okay, so continuing. From R, 5 is the opposite, and 12 would be the adjacent. Okay, so now that makes it a little bit easier to set all these up. What over what for sine of R? 5 over 13. Cosine is what? What is cosine? What over what? 12 over 13, the adjacent over the hypotenuse. And tangent. Opposite over adjacent. Yep, 5 over 12. Thanks, Lexi. Okay, so that's according to angle R. Now we're going to switch that. Now we're going to go over and we're going to talk about T. So now they jumped us up to here. Okay? Now the opposite is over here. This opposite is 12, and is 13 or 5 the adjacent?
13.
Don't get tricked.
Oh, I thought that don't change.
5. This is not going to change. Once we know where the hypotenuse is, it never changes. So even though 13 looks like it's next to it, that's automatically the hypotenuse. That's why it was the first thing that I labeled. This is the adjacent. Okay, so don't get tricked on that. That's the reason why I labeled the triangle first. We jumped up to angle T. So I drew angle T in blue, but this is no longer the opposite. That was the opposite of R. Yeah, but this one doesn't. Once I label that, that's always the hypotenuse. No matter what angle I'm talking about, that one will always be the hypotenuse. So now 12 is the opposite and 5 is the adjacent. Okay, so what is sine of T then? 12, the opposite, over 13, the hypotenuse. Okay, what's cosine? Adjacent over hypotenuse, yep. 5 over 13. And tangent. Okay. Now, they have a Regents question that'll ask you which of the following are equivalent. So if we look at this, which of these are equivalent with each other? Sine of R and cosine of T are equivalent because they have the what? Same fraction. What other one is equivalent? 12 over 13 matches this 12 over 13 of sine of T equals cosine of R. Because they have the same fractions. Okay, so when they ask you that question, that's what it is. Markayla. Yes. I have a class next period. Okay. All right, so we're going to flip over to the back. All right, now that we're on to the back, now, I don't want you guys to get confused, for those of you guys that are aiming for the Regents exam, of a squared plus b squared equals c squared versus, this is the back. Oh, don't pay attention to that. That's the partitioning from the other day. Versus SOHCAHTOA. The question is, when do you use a squared plus b squared equals c squared versus SOHCAHTOA? They're both for right triangles. This is the Pythagorean theorem, but this is for sides only. When there's no angles given at all and they're not looking for an angle, they're just looking for a side measurement or for you to prove it's a right triangle. So This is for missing sides.
This is making me second guess about this goddamn regions.
Or to prove it's a right triangle. Okay, SOHCAHTOA is when you have a mix of angles and sides. Yep. So you use a squared plus b squared equals c squared when you're trying to find a side.
So
You use SOHCAHTOA when you have an angle.
So when you see angles, just know SOHCAHTOA.
Yup.
And not the other.
Okay, so all this page is SOHCAHTOA. Because we have, if you look at every picture on this page, it's all angles. You have an angle in every single picture, so you know to use SOHCAHTOA. Okay, now, for this one, they ask you to find a missing angle. Let's figure out, what are we given? This angle, obviously. This is the hypotenuse. And this is opposite the angle that they're looking for. Okay. So the question is, I don't even need the adjacent. I need to know, am I using SO, CA, or TOA?
Wait, I forgot what the
It's up here. I rewrote it up here. Is it SO? How do you know it's SO? I don't have an A. I have the opposite and the hypotenuse, which alerts me that I'm using the SO, the opposite and the hypotenuse. So I'm using sine. Sine. Right here would go the angle. Do you know what the angle is? It's x. We don't know what it is. Equals, what's the opposite? What's the hypotenuse? Over 12. We're setting it up. Opposite over hypotenuse. What's hard about that? Okay, so continuing. What do we do when we don't have the angle? All you got to do is hit second, sine. We can't do sine of x in our calculators. It never works. Can't take the sine of something you don't know. So if you do second sine, and then just type in that fraction. 5 divided by 12. Close it. Hit enter. And just like the front, we would round it to the nearest hundredth. Okay? So all I did was second sine, and then I typed in the fraction. That equals 24.62. It's done. I don't have to do anything else. All right. Here, what are you given? I'm given the angle.
given adjacent and opposite.
I'm given the opposite. Yep. And the adjacent. No hypotenuse. So it's TOA. So we know it's tangent of the angle equals opposite over adjacent.
So we're using cos, right?
Tan.
So second tan.
So since I'm looking for the angle, I've got to go backwards. And for us, that's second tan. So we would do second
48.50.
tan. So what you would see on your calculator is this, and you just type this in. You just put the fraction inside the parentheses. Second tan. Okay, so second tan.
Are we going to make it 68?
Now remember, this 6, remember the rule is 5 and above, give it a shove. 4 and below, leave it alone. So this rounds up because that's a 5 and above. So it's 48.58. Meaning the angle equals that. Oh, I was listening to you, Robert. It's not like I don't pay attention to you guys. No, I never do. horrible teacher. Yes?
This is all going.
Okay, what am I given in picture C?
The H and
And then this is next to it. So, yep, this is the adjacent. That's the ka. Yep. So we know that we're going to use cosine of the angle adjacent over hypotenuse. Okay? Again, you can't stick cosine of x in the calculator, so this is where you would do second cosine. Okay, so second cosine. Oops. Wrong thing. So that was my second one to confirm, 48.19. Okay, anything hard yet? Okay. And even if this is an extended response on the Regents exam, guys, if you got to here but didn't know where to go from there, they would still give you partial credit. You know what you're doing. Okay? Yeah, it's simple from there. Put it in the calculator, but some people can't remember second sign or stuff like that. We'll be doing the homework in class since I cannot send it home. Okay. Tomorrow. All right. Finishing here down to the bottom section. The bottom section gets a little bit harder, but not by much. Okay, so here, did they give me the angle this time? Yeah. Yup. So I'm trying to find a side. Okay, good. She recognized this as the hypotenuse. What's this? This is next to it? Yes, this is the adjacent. So which one am I going to use? So, ka or toa? Let's take a look. We have adjacent and hypotenuse. So we're using ka. We're using cosine. Okay, so soka toa. I'll write it up here just because we need it again. So we're using ka. So I'm going to do cosine of 56. That's the angle. Equals adjacent over 13. Now this is not hard. Do this, please. Nope. I'm making it into a fraction, so I can do this. No, that's an A. Okay, so now we don't have to do second cosine, guys. Can you stick cosine 56 in your calculator? It's a number. I can stick cosine. Now, for this one, we have to solve these like we were before when we were setting up proportions with dilations. Okay? Cosine times the 13 equals the A times the 1. Well, what's A times 1? Just A. Equals, so this side is going to equal whatever cosine of 56 times 13 is. So I'm cross-multiplying so I can solve it a lot more easily. Now, be very careful, Mari. Did you forget to close your parenthesis right here? Yup. What would this round to the nearest hundredth? 7.27. Now, I'm going to ask you a question. Does it make sense? Okay, because the hypotenuse is supposed to be the what side? Yup. She said the bigger side, the longest side. So the hypotenuse is always supposed to be the longest side. So if you have 13 here, this number down here better not be bigger than 13. If it is, you did something wrong. Okay? All right. I'm going to jump down to C because C is a little bit easier. And then I'll go to B. Okay, so let's do the C. What did they give you in this picture? Besides, they gave us obviously the angle. What's that? And what's that? This one's the adjacent. And this one's the opposite. They did not give you hypotenuse. So ka or toa? It's toa. So we're doing tan of the angle equals opposite over the adjacent. Okay, so again, yeah, C over 4. Yeah, I cross multiply. Tan 38 times 4 equals C times 1. So tan of 38 times 4 equals C. Okay? Yeah, if you do it, it should come out to be 3.13. Making sure you close those parentheses or it's going to get the wrong answer.
Oh, they gotta be closed, like.
You have to close this parenthesis right here, or it's going to put the times 4 and it's actually going to take the tangent of it. We only want to do the tangent of 38 and then multiply it by 4, so we have to close that parenthesis. Yep, 3.13. Okay, so those two were pretty easy. Okay, and again, if you can get them set up, but you don't know where to go from there, they at least give you points for setup. Okay, so what do they give you here? The angle, the opposite, and we're trying to find the?
What's the A? We gotta find A.
Gotta find the hypotenuse.
Wait, hold on.
So, ka, or toa? So, ka, or toa? It's so. You have opposite and hypotenuse. So this is going to be sine of 35 equals opposite over hypotenuse. Okay, so the quick question, what do I do now? It is B, right here. Yep.
You got times.
It's like, what do I multiply together here? I cross multiply. Sine 35 times B equals, what's 6 times 1? How would I finish solving this? It's like solving this. What if I said 2x equals 6? I would divide both sides by 2, right? So you do the same thing here. This thing right here that's in front, you would just divide by it. So you're dividing by sine of 35. In other words, the sine and the b are switching places when it's like that. Because that's exactly what's happening, and I'll show you in just... So b equals 6 divided by sine 35, which would happen if we just switched these two. And again, you get partial points for setting these up at least. Yep, 6 divided by sine of 35. Okay, so B equals 10.46. Now, quick question, does it make sense there? Yes, because it's longer than? It's longer than 6. This side right here, again, must be the longest side.